And if he
to the
does
quiz,
tell him
it says
to tell him.
greater than 1 is supposed to be less than 1.
Dude, I can't believe I'm
No,
moving
tell him
it.
to call him.
Fucking hurt my arm.
Yeah, you definitely do the best.
Real stress and engineering stress. I was asking which one, no,
I don't know what school he's like.
Engineering stress and true stress.
true stress.
What's
True
his last
stress.
name?
Okay.
I don't know.
Right, I mean,
And then
Yeah, like
it's-
have a really like.
engineering
mustache.
stress is always greater
Was
than
he short?
true stress.
No, he look a little taller.
I hope.
I have to see a picture.
Let's
Stop it.
Why?
It's because he's the
Hold
coach of
on.
the volleyball team.
So true stress takes only the
It's like less than 1 or something.
true stress should be less.
Less than 1.
We're doing torsion, right?
Yeah,
Not
Yeah.
okay, alright,
Means less than engineering stress.
yes.
this is steel, right?
Yeah, it's the
Right? Engineering stress should be more because it takes only additional area.
I know.
Yeah, definitely should use that financially when you need to buy a tripod right off the bat. Fuck.
No, the true stress should be more.
Thank you.
No. So that is.
Wait, you're doing it for steel right now?
I remember true. Because the calculated stress is just kind of an approximation, and then the engineering
Right. This is the thing.
Or no, I don't know. Hold on. The question, I looked it up and it was less than 1. After, the results came out. I was like,
Feeling
looked
this
at
for
it
the
and I was
entire
like,
time.
I don't know.
You just need one hand to
It's
do
a
Excel.
problem. This
It's not a problem, it's just a concept.
That's why.
The question was, is true strength is always greater than
Bless you.
engineering strength is the answer.
Yeah, true. Basically,
Cut
this is
that
what I
already.
answered.
Bigger than?
That's what the correct answer was. True stress and compression is always
Is this
greater
what I'm
than
asking?
engineering
I
stress.
think so. I don't remember the specific question.
So this will keep on.
It was like basically which one
Increasing.
which one has greater stress.
So this is
true
the right
or
one.
engineering.
You know, like see, if you're stretching,
What the
Like 300, right?
if you're
No, no, no,
stretching,
it's
the
like
areas
800.
keep on decreasing, right?
Damn, why the
This
fuck
factor
is this from
decreasing,
3000?
this is-
Shit.
This is constant.
Yeah, they're both like
Like
3001.
Start,
Yeah.
like this is your.
Yeah, they're both data was like
This area
3001.
I'm going to
Uh.
start, and it will not change. So this will be
Except with Ludo, was like way worse though.
throughout
Way
the
worse.
stress state.
Yes.
That's around.
Dude, I cleaned the data for lab too, and that shit was like straight when
True
it came
stress
out.
is more than.
Should we delete the zero values with the first three?
Sorry?
Should we delete the first three zeros, zero values?
Also count.
Professor, there's a technique where you could go to insert and you could click on data, and then you could even like delete like you could delete duplicates, like duplicate data. Let me see if I could go either. If it has it, you just Oh, it's my bad. It's not on the insert. It's on the data column, and then you go to Let me see. I think it's data. It should be next to remove
Remove
duplicates. Yeah. And then you could
It's under data tools.
Like next to column or text to column.
It's
right
on the
there.
right side or
It's
something.
right there.
right there. Yeah, you could click on that and then select your data and then remove duplicates. That way you could.
So you have to select all the data.
Uh-huh. It's not gonna work like that. It only works like per row. Because when it's like that means like it selects it and it's like no duplicates found. But if you do it like per row, then it shows you like, oh, you have like 400 duplicates or 100 duplicates.
So
No, I selected all of it. It
Huh?
said 57 duplicates.
Really? All of it? Okay.
Where does it say delete duplicates?
But yeah, I think you have to.
Go to data,
Right,
right?
and then where?
Once you have
It would be
something
nice for the
selected,
This
next
like
to, Hey,
press
where is it?
Control All,
it's
Control
right
A.
here, under data tools.
If you press Control A and then press and remove duplicates, it'll like give you like a thing for all the columns, and then you just have them all selected. You click remove duplicates and.
Oh yeah.
Okay.
I'm just first delete all these things.
Wait, from what roll, Professor? 63?
Yeah, till 63.
Okay.
Angle is 0. There is no
Oh,
point.
yes.
Well, they're that backfired.
What do you
Now
mean?
let's do the first delete that.
No, he's gonna go back to it.
Yeah, well.
'Cause 63 entirely, right?
Yeah, so 1 through 63 you delete, and then the remaining data you move up.
Yeah. Okay.
Then delete this stress, we don't need. Means we will calculate our own, I don't think so. this is-
Oh,
Wait, we just delete the whole
Delete
column
stuff.
D?
PSI?
All D.
Just all D only?
Dude, I cannot do
Just want to keep it.
the arrow and the control shift. Is like I'm.
So first column is torque. You remember we calculated Newton mm, right? So we are going to convert it. Okay. Is it done?
Oh my god.
Yeah. Oh, dang it.
Pound.
Bro, dude, your finger's like flapping all over
Right
the
now
place.
it is inch LBF, right? Yes. Okay, so this is basically a force. And this is your distance. Okay, so 1 LBF, and you have to convert it into a Newton. And 1 LBF is 4.4482. I'll check. And inches 25.4 mm. Okay. So your torque will be
Yeah, delete the whole D.
1.482 multiplied by 25.4. So this is your torque. Just multiply that, and I did 4422.
Yep.
Okay, so this is your torque. Torque is force into distance.
Thank
right?
you.
You're even pointing.
Oh yeah, I need to put it there.
Hey Brian, see you.
We will give a standard number. Do that too fast. What's the multiply answer?
This shit hurts, bro.
Says 2.9 something. Just make it 113. Just like 113. Okay.
Yeah.
Okay.
Yeah.
So what you are going to do is you are going to multiply column B with this factor. Okay, that's it. So you know that the equal to then this column multiply by 113. Right?
Dude, I can't reach.
And then it was.
Damn. Times 113. Okay, I got that data. Okay, cool.
Expand to get the
Is it okay if it's 112.54?
Because it might not be.
Which one? 113?
For,
You only got two.
new
So as long as you feel like you only got two duplicates.
Is it okay if I use 1112 or
Just highlight the space.
112.33?
3
Hmm.
54.
5 4.
It's fine.
About yeah. But you should
Another
get
way
to
is
the
to highlight
same
that
one
space,
1.
click delete, and then
The
it'll be like shift
2.924.
shells, and you just shift the cells like that.
Okay.
Yeah,
I got like that. I just multiplied this like that.
Yeah.
It's weird.
You know what I'm saying? You didn't do that, that's fine.
This one's
It's still
I think this.
Yeah, so
Okay,
delete,
so-
and it says shift column.
Dude, my
Let's
arm
find
is
the
fucking
modulus of
hurting.
friction.
Undo it, and then
So torque and
Oh, I see.
modulus.
Yes, yes.
Modulus of rigidity. Uh-huh.
Modulus
And then all the whole
Or shear modulus.
Sure.
Okay. And it is going to be in a megapascal. Okay. What's the formula?
It's torque It's just times 1/100.
Right. T is in Newton meter. There is L, theta is in radians. J is in mm, which is equal to pi d4 by 32, right? What was
Boom.
the standard? This is the sample, right?
What the?
Like that. So this total length was 18 inch. Gauge length was 12 inch. This was 0.75 inch. This is 1 inch. Right? That's it, right? This is what you need. So what's the dia? Dia is 0.74 inch. So convert it into mm. You got the idea, right? First mm is equal. Torque you have, you calculated, right? Torque column, theta column, L from the standard is a constant, J is also from the kind of standard, like you need D, right? Pi d4 by 32. Solve this. In the mm.
Okay, so
So converting, solve it all in mm. Give me the final J. Yeah, you do.
So for L use 12 or
So gauge length you have to worry. So only you have to check the gauge length is 12 inch. Please draw these thing, in the report. Or you can go to laboratory device. Inch, that is inch. Okay. And you need everything in mm.
J is the torque.
Polar movement of
J meters.
No,
What's the fucking unit?
torque is T.
Torque is T.
Yeah, which one's J? What does that represent?
J is the last one, polar movement of inertia.
Which is pi d to the fourth.
Yes, pi d4 by 32. This is the unit.
For diameter, that's d represents diameter, right?
Yes.
Would we use 0.75 or 1 inch?
Only the gauge one. The breakage happens only in the gauge
Oh,
area.
okay, so
Right?
0.75.
So that is a gripping area. You don't consider the gripping area. So D is
So D is diameter. So it's
what is D? D is 0.75 inch. So you have to convert it into a mm. Okay, before doing all those. Everyone should do. Give me the J. I got 12903, but I don't have a
This is 0.031. That's what I got.
point. No. It should be a big number.
You're talking about for the conversion from 0.5 inch to.
Oh, yeah, let me convert it.
No.
Oh.
Just a J.
Oh.
Like I did it also.
Oh, yeah, I didn't convert it.
What'd you get? No, because we're doing it for all the cells, right?
Just
I got like
12,900.
I got 12903.
Yeah, I got that.
You got that?
Yeah.
Okay, then
12903.
In millimeters, right?
MM4.
Yeah.
Yes. MM4.
Uh-huh.
Yeah, yeah.
I got 12929.
Yeah, that's what I got.
Oh,
Cause 0.5,
Oh,
I just
that's
did the
the
conversion right here. It's 300.
Oh, okay.
Like 20 down. No, it is. So then you cube that.
Entire length.
Oh wait, no.
Or
That was for something else.
No, that is for length, I think. 304.8.
Yeah.
That's
Oh
the
no,
length.
no, no, my
Should
bad,
be
my bad.
19.05.
Yeah, no, yeah, it's not my bad.
It's
That's
11.
a different number. That's a different number. 19.05, yeah. And then I fourth rooted that. Yeah. And then I multiplied it by prime and divided it by 52.
That's fine, you use yours.
Okay.
What did you get?
I got 66,000.
No, that's totally off. They got 12929, we got 12903.
I think he needs 66,000 when you actually input it to Excel.
Oh yeah.
When he puts it into Excel.
Yeah.
Oh.
Like the whole thing, the whole.
Oh,
Yeah, yeah.
Then it's a good idea. I'm just asking about the J value, I want to match because I think mine
Oh.
is. Okay, let's,
To the
let's,
Excel.
let's do the modulus of the G
To the Excel.
here.
66,000.
How do you do that? The formula is T. You're going to start the bracket, and T is this one. Okay, multiply by
304.
L. L is 304.8, right?
Mm-hmm. Parenthesis close.
Hold on, my bad.
Divided by.
Oh, you close the parenthesis, right? Because you need to multiply those two values first.
Yeah. Good.
And then, yeah. And then the angle.
Theta.
Oh, I did the wrong one.
J. J is 12903. Yeah, this is, yeah, G, yeah, same answer.
Oh,
Yeah.
okay.
Good? Do fast.
Why is my thing not showing?
12903.
It's the same answer, but
You have to change that.
it's because of
Formatting.
Oh, yeah.
Which one?
129.
And then
Mm.
7622999.
In general.
What? Huh?
Those are the answers.
66759. 58062.
903.
Cool. My hand hurts.
Yeah, Derek, first thing you should do before fall semester starts, buy the order for a tripod.
Yeah, that's what I'm gonna do.
That's.
This shit's. My hand is in pain.
So you create the two new columns, shear strain and shear stress,
Oh, with the,
and that is the formula. So now the next thing you have to do is create a shear strain and shear stress. You know, we studied those formulas, and you have to create two new columns. Please be mindful of the units. So what you're going to do, shear, strain doesn't have any units. Shear stress. Okay, do that.
So R for the overall. Honestly, idiots. What's the radius right here?
I think that's pi.
Oh, it's pi?
I don't know.
No, no, it's R.
Yeah.
R means radius.
Yeah, okay. So shear strain.
yeah, there's hard having Derek, you have a potato gym. You have a potato gym.
I have. It just hurts because I'm holding it for like my fingertips. Sucking shit. shit, stop recording. Just playing.
Yeah, nah.
So if I don't have the remove duplicate button on the data, then is there another different way to do it?
You just have to
I
manually
didn't do
delete it. No, because you just have to
I didn't
manually
do that.
delete it.
You didn't.
He didn't do that. He just manually deleted.
I just deleted the initial data, the 0, 0.
So from
Hang
row
on.
For
1
every-
to
so
63.
okay.
Yeah, that's what he did.
Gotcha.
Why is it so bright? It's like so bright there.
You use the angle and radians?
Yeah, always.
Okay.
I'm putting that right there.
Yeah, Derek, Derek should invest in a tripod.
Yeah.
So you're gonna do that first thing the fall semester starts.
Yeah.
Oh no. J is 110.
I'm bringing these up with column.
Is your first number like 2.4 something?
For strength?
Stress.
Yeah. For stress, Yeah. 2.45.
For short string.
Lab 3 for fluid is due today, huh?
Yeah.
What do you got?
Then plot the stress strain curve, find the toughness shade, find the maximum torque, maximum stress, modulus rigidity.
I don't think I got the joules. Oh wait. Never mind. I see it.
Good, should I do?
You want them all on the
How do you get the torque again?
Torque is
No, torque is
multiply
given.
force times distance.
Torque is given, you have to just multiply this column
Yeah. Okay.
with the 113. In here I explain why I multiply with 113.
Right. Okay.
Okay.
Did you gauge it, right?
Yawn.
The strain is it the gauge length or the full length?
For the
That's why that's the
It's
only gauge length. Always. Because that is a gripping section. You know, it goes inside the that chuck.
Okay, yeah. Stress strain guide, and you said you wanted the max for rigidity, strain, and stress?
Yeah, the rigidity, basically you have to do that the selection of the certain data from the plot. That will give you the rigidity,
This guy.
then maximum stress, basically shear strain, and shear strain, maximum shear strain, and shear toughness.
What's J? Joules. Oh, sorry. 104,535. Right?
No, J is different. J is 12903 something. You find 1 to no.
From that.
Yeah, pi d4 by 32. That's it. D is going to be 0.75 inch.
Oh, you're using inches and not millimeters.
You have to convert it to mm.
The
Yes.
modulus strain and stress.
Mm-hmm.
Huh?
Okay, so for the max for rigidity, it's 6,600. 6,600.
That is a torque, right?
Equation for joules.
No, that's rigidity.
That one, or that one.
What's that?
Alright, 129.
And then the strain is 0.
Oh.
That doesn't make
See,
sense.
this is my solution.
Validation non-stop. Wow.
Oh
What
my
the
god.
heck?
Wow.
And that's the max value for all of them?
And this is rigidity.
This is-
Stress.
That's
Where's your rigidity?
Yo, look at that.
This is the rigidity. No? It's like the data.
Oh.
Oh,
Beginning.
wait.
I want to see the shear strain. Oh, he clicks
Oh, I
on
thought
it.
you meant like the rigid, like the, because you know how you made us calculate G?
Yeah.
So I thought like the max value of that one was your rigidity. That's what,
I think
that's what I'm saying.
Generally we take the average though,
Yeah.
but that doesn't give a right answer. You just do with the, because elastic limit you have to pick. Or you can do the averaging of the first 40 data, 30 data.
Yeah, so what do you?
Because you have to see only the elastic region, you know? You can't take the entire for the maximum. Or it should get the, but
No, but they should, no, I got the table, right.
table right? You know, just take the average of these then. Average of first 40 data. You should land it to something.
I just copy and paste the graph and I just do what you did and select the values.
Yeah, that's the easy way. Good. Cheer.
Oh, wait.
He doesn't want his point.
Did you click
No,
on
it's
your
the, you
F2
need to get that
box
straight line.
on the other one? So I can see what you're putting.
Remember modulus?
Yeah, or the, it's the, what's it called?
No, you try by your. This,
Where'd you get the 9.5?
this is the radius.
Oh, okay, that's where I'm going wrong.
I think you're using D correctly.
That's R.
Yeah,
Right.
R. Yeah, R. It's
Okay.
nice.
I didn't get like, you got like 4,000, right? 400,000,
Yeah, 41,088.
Just linear? I got 39, I got 39,000.
I think so. You because your J is different, right? 1
Yeah.
to 9 to 9.
Okay.
That much. 1 gigapascal.
Stop recording now.
And then you wanted that?
Shear strain, shear stress basically maximum strength, shear strain. Then shear toughness,
9.5.
and then maximum torque. For maximum torque, you have to just use the theoretical concept.
Max torque, you just do the max of that whole column, right? Or not?
I think the maximum torque is going to be where you get the maximum stress. Right? R and J is constant. So where the shear stress is maximum at the point, your torque is going to be the maximum at that point only, right?
Oh, okay.
Right. So similarly, you have to pick it.
For strain and stress, is it I or is it R?
It's R.
R.
Okay, so I think I got everything.
Okay, yeah.
Good.
I think I
What
got
do you
it.
want to do?
Okay, now I'm doing it to, okay, now just see. So shear strain is R theta by L.
Yes.
What is R?
It's diameter divided by half.
What is the answer?
I'll divide by 2. It's, oh.
9.525.
9.525. So okay, is equal to R theta. So you can say 9.525, right?
Yeah.
Then multiply by theta should be in the radians. Close the bracket divided by L. L is 304.8. Good?
Yeah. 368. What the?
Good?
Yeah.
Wait.
Everything is given now.
Yeah.
Should be fine.
Give it a
I'm gonna use,
The toughness is the
5.
Give it a
it's the
Area.
area on the
You have to go to that
I
one.
gotta use the Wolfram.
Wait, hold on.
4.
What's our radius? 1 inch, right? 1 inch times our.
No, the radius is 0.75. Because that's where you pull the thing.
Always the gauge. That is a gripping. Forget
You're
that.
dividing by
Okay,
304.
so this
Yeah.
one
I mean,
is the
yeah,
max rigidity.
It's
So
too
you
I
want
don't
the
think
shear
you want, I don't
stress?
think, I think that
There's the shear
yeah, I think
stress
that's what I'm
plus equal
thinking.
to
So that one doesn't really need
T.
it.
304.
T is in
But this one
newtons
is the
per
max strain, this one's
This
max
one?
stress.
multiply by T into R. R is 9.525 divided by J 12903, right?
Okay.
Yeah.
So this is my shear stress.
Let me see the shear.
It's a V by 2.
Oh, okay. Right,
R.
right. So 4 squared, which is here.
0.375 inch. If you convert it into
Yeah.
Minimum is 9.575.
That's for M. And then that's for G.
Oh, and T F. My bad.
Professor, is there, is there
3 or
a
4.8?
value that we
Yeah.
choose to put as a limit for this one?
For the last one.
Or is it?
Yeah, you have to choose the last one. But last one we just, this straight one deleted.
No, you have to do it twice. I don't know why.
What the heck?
Does it
Just
trigger?
use this
Click
one.
off of it, then click on it again, and then copy it. It does
It's
the
like
same
around 0.963 or
We should get this is the equation.
Wait, you said what?
No, it's,
Don't
it's,
use
it's
this.
that.
Okay.
It's literally that for M.
9.525.
I got 426.
Yeah.
And just find toughness.
2.5 or 2.6?
For 26?
2.5.
Oh shit! Oh, not 2.6.
What did you stop at?
Did you put 2.6 in the equation?
0.97. Point
I think so. I'm guessing.
Did you fix your stress strain graph so it gets overloaded?
That's
No,
for
I
the
didn't-
modulus,
I didn't do
the
it.
rigidity.
I didn't do that. I didn't get rid of the
Is your
six one,
first
I know
one
it's fine.
3.6813?
Yeah. Should be that.
Yeah.
Really match with the.
Toughness is
E5.
425.
Okay, let's plot a stress strain curve. Okay, simple. Plot it fast. So this is the
I
plot.
didn't get that.
Good. What you are going to do is next,
425.2.
you are going to find the modulus. Same thing. Select the data. How much data you selected?
I did like 200.
I did 250.
It's like the same thing.
I did 2.5 though.
Oh, I did 201.
What should I do?
None. Whatever, bro.
It's okay, man.
No, man. He's disappointed.
Yeah, I got 40.13193.
How did you change it? Was it not saying? Was it not saying something else? Or am I tripping?
You
I'm
might be
not-
tripping.
I'm not-
You might
I
be
thought I saw
tripping.
it say like 3 something and then it turned 4.
No, no,
Oh.
I intercept type like
Yeah, it's
it
pretty
was
down.
not starting from origin, so
Bro.
that's why. So G value is 40.193 gigapascal.
You can click on the top.
Good. That's the first value. Shear property. The first shear property you are finding is G, that is modulus of rigidity, is going to be 40.193. Okay. You know all those things. Okay. Now find the shear strength of a material. Shear strength of steel. Okay. How you are going to do that? How you are going to do that?
So you put 200
The what?
for the
250 you make it.
250.
Shear strength.
I got a different number.
Selecting out.
Is that not the max?
Just the maximum value of the stress
There you go, that makes
column.
sense.
So the maximum is 506.386. Good. Shear strength is done. What is that?
Wait, Professor, what's the full number for that one? The full number is only 506
Oh,
point.
no, because you put it in gigapascal.
Oh, okay.
You should do together, and finish the other material too. And just at home write a report or submit it fast.
Are those all the values you need, Professor? Or are there other values?
Values
Did
in?
you, did you
Like,
go
are those
to
all the numbers you're looking
200?
for? Are we looking for anything
Take
else?
a
No, toughness have you done?
Yeah, we
250?
What is the torque?
5 feet?
For toughness, what I got?
Yeah.
I got 426 for toughness.
No, for
Oh,
torque.
okay.
What is the maximum torque?
Oh, the
Oh,
506.
No,
No.
that is shear strength.
Oh, for Newton by Newton.
This is not.
Yeah.
No. The shear strength is all 506, which is the value you gave me.
How do you get to that?
Okay, now I'm going to calculate the maximum torque because I need maximum torque to find the power, right? Maximum.
I got 685,970.
Yes, exactly. Should be. Okay, maximum torque, how you are going to find the maximum torque? If you see the formula,
Yeah.
shear stress is TR by J. R is constant, J is constant. Okay, that is not changing. So basically, if we have a maximum shear stress, so torque is going to be maximum at that the same point. Just see where this number lies, 506.386.
Yes.
It lies in here. Okay, so corresponding is your maximum torque. So maximum torque is 685,973. Six eight five nine seven 3.169. Okay, Newton Ampere. Okay, this is the third value you got.
Oh, that's it.
Maximum torque. No, the toughness, and then we have to find the power. Just find the power calculation if your shaft is rotating at a speed of 1800 RPM. Power transmission, sorry. Power transmission if your shaft is rotating at a speed of 1800 revolution per minute. Okay. Any doubts? Good.
No, so-
Can you show us one more time how you found the maximum?
Okay. So maximum torque is basically, see the formula where you are getting a maximum shear stress, right? Because R and J is constant, so shear stress is directly proportional to the torque. It's a constant. Okay, it doesn't matter. It will not change. So shear stress, where you are getting a maximum shear stress, your torque is maximum over there. Okay. So if you see your shear stress is maximum is 506, you are going to find where is 506. It is in here, right? So corresponding, this is my torque.
Can you see
D column, see it's 685,973, whatever. Okay. Now the shear toughness,
Oh, but mine's different. That's what the.
and you know that how to do that. Just to go to that. First, what you are going to do? Select data. Just remove. How many you remove? You remove the data initially for this, for toughness, for this thing.
I didn't.
How many? No, but how did you get the trend line? How did you get the equation?
I just did like a polynomial for that one. So
It worked, huh?
yeah.
It
gave me-
doesn't take into account the dip at the end.
It gave me like what was it? For the toughness, it was 425.26.
Is it quarter or four?
I did like 6, but
But it is not starting from zero, no?
No,
not really.
When you start from zero, it starts to like go.
It will take that thing then, right?
It starts to pick up.
Yeah, see, you have to delete the data.
oh, so our toughness is wrong.
Means at least it should be close to the, zero. So that's my point. I don't know how many you have to delete.
2500.
No, it will be too much. So it is not changing much. It is at 2902. Or you can just see the data directly, right? There's the
Probably like 600. If I had to guess. You said 2800.
It's regular. It's fine.
See? Just last 4 data where the stress is decreasing drastically, right? After maximum you don't need, no? Even I will retain this 504 too. Let's see. Last 4 data you can just delete it. Where the significant dip. Yeah, perfect. After significant dip you don't have to take, right? So now do the tendrine and you're going to make it polynomial. And let's see what will happen. You guys are following, right? Good, right? You know why I deleted that initial data.
Mm-hmm.
I don't. Why?
Cause that, to cut off that end line that dips down.
Because that is, will not give you
mess
the
up that end
Oh,
line.
that,
proper
Mm.
curve.
okay. And that's on the original stress strain curve? That's.
Yes, yes, always.
Right, so we just throw those away?
You didn't have that on yours? Or we down the line?
Mhm.
No,
Oh, this guy right
on
here.
that side, yeah.
Yeah, I deleted that.
Oh, okay, yeah, yeah.
But this one we're deleting too?
Did you do, no, did you do, did 6 line?
Yeah.
You tried 5, so
Oh.
it looks.
Look at that
I
word
did 5, it
tiring.
looks good.
What in the hell?
There wasn't a
There's always no.
This looks nice.
Yes,
Uh,
beta.
Oh, wait, I said.
Okay, Derek,
No, I'm
look at the
just
number
checking, I don't know.
on my thing for the chart.
Like, if you do, like,
Just put your iPad there.
yeah, click on settings.
Oh,
and then-
Yeah, so that should be the number to match up to get that chart.
299.
Yeah, so and then that's how it should be
Log
for
is
the
good?
chart.
I think log might be
Or.
Why did you do shear stress megapascal?
No, it does.
You just copy and paste, but I don't know what number he did.
Yeah, logging is nice.
So just ask him what number he used for the second chart.
Like, no, for shear stress. Like, how did you get the.
Now it's not working.
This.
Oh, you still didn't get the equation for that?
No.
I'll show you after.
Alright.
So, upon number 6.
So not log,
That Wolfram thing, right?
You get the same number, or does it change because of
Bro,
Oh,
Derek, you're
yeah.
slipping. Bro, it's like looking into the light.
I've been handling my hand
What was
like
the
this
angle
for
you guys
42 minutes.
Professor, for the first chart, did you select the set intercept, or did you only do display equation on chart and then display arc?
Don't do the set intercept.
Okay, yeah, just double checking.
Oh, so you don't make it zero?
It is not working. It is taking a lot of
Yeah.
data. You can, let's do that too. I just want to check 0.9625. It's too straight.
I was say Derek probably that holy water's messing with you.
What
You
the
gotta
fuck?
give me- you gotta give me.
Yeah,
that's like,
423.
that's like around the same
It's around the
value that
same.
we got.
So now let me take the intercept.
Okay, what is that?
So
It's, I don't know why, I figured,
It's like
remember that
the-
day I was like, yeah, remember that day I was like tripping out? Cause I was thinking for the
Well-
I learned that day.
Damn it. It fucking
Control
hurts.
copy, click off.
Guess so,
You need to take a shift on, see.
take a shift.
Oh,
Just making sure this thing is right.
Yeah. And then control copy again and then still didn't work.
Where'd you get?
What the?
what is 423.28? Okay.
You got what, Professor?
I got 420. I'm just using the intercept. It's not making big difference.
No,
With intercept, without intercept.
Oh.
No, it
Oh,
doesn't.
I did
You
both.
I have 0.76 and I didn't put the intercept.
Yeah, I did. You see, with intercept,
I just
490.
downloaded one.
Without is 420. This is not making a big difference. So you can take with intercept, without intercept, doesn't matter. So values will be around same. With
Okay.
intercept, without intercept.
I'm gonna just keep it at 4.
Okay, so you can have the shear toughnesses 423,
Wait, what?
whatever, 284.
Oh, straight shoot.
Good? Okay, shear toughness is done.
Mhm.
Shear strength, shear modulus. Now we are going to find the, any doubts in this?
May I see your shear stress diagram, the second graph? Okay, yours, okay.
I took the 250 data, selected data.
Okay.
Only 250. So now the shaft is rotating at a speed of 1800 RPM. Suppose you are using this material to make a axle. Okay, suppose this material you are using to make a axles for the car, and your requirement is it should rotate at a speed of 1800. So what is the power transmission? You have to find what is the power transmission. Do that. What is the formula? Power equal to 2 multiplied by pi 3.141
Times 1800.
n, right? Yeah, 1800 exactly, and then
Divided by
T,
60.
and it's going divided by 60. Do that. So
Okay. Do you want the answer?
that was the answer.
188.5 radians per second.
180. Okay, let's do that.
Oh, RPM. Which is what is it? 1800.
So basically using this thing, okay.
And then
Tau maximum you have to use. That's why we found the maximum torque. So you have to use the maximum torque to find the power transmission. Okay. So it's like 685,973.169.
So
I did wrong, huh?
Divided
yeah,
by
divide by 1,000.
Divided by 60?
60, right?
Yeah, I got that.
Yeah,
I got
yeah.
that value. I got that as well.
And then you put the max torque and divide it by 1,000 to get it Newton mm, right?
No.
That is already in Newton mm.
Oh, that's fine.
You know, so this data you get it from the D column. And column D is already Newton mm.
Divided by 60. Yeah. 21.
So it's going to be that much power. Okay.
So which one do you plug in for N and T?
Sorry?
Which number on the
So that was correct, Professor? The time?
1800?
This power, this is what I got. That's what I got.
Yeah, I got that one too.
Done.
I got like 95.
We'll put it down.
Just hold it from the top, so if you can set it and then just hold it from the top.
Yeah. But then he's blocking.
Yeah, but just try to do it at an angle.
It's like a big number, like 6,000.
Yeah, and then you just have to hold it like that. Yeah, but you got the
Can
whole
you do
light.
the security? So Monday we will go to the lab, and Wednesday we will do the last topic of this course.
Which is hardness.
Harness is done. Professor. The lab report 6 is for hardness. 6
What?
5. Professor, we have class here? No.
No, right? Okay. Because I think you sent some message saying tomorrow we have that. Or
Really?
bring your computers. Unless
It was for today.
That was
I
for
was
today.
today.
Oh, I read it.
Incorrectly.
If you sent it yesterday, let me just put your.
Yeah, just so you know, bro.
Good. Can you do for other materials? Any doubts in this one? And do for second material, give me the answer so that everybody should be on the same platform.
Why is it just open?
Powers in watts.
What's Pascal second?
It's gonna be a long video.
Let me
Yeah.
get this law just for a
Oh,
moment. Okay.
Easy peasy. Okay.
I should just end it now.